Hi everyone, and welcome back to Scaled Factory. This is part 2 of our Trust Vectoring System series. In the last video, we designed the gimbal, the heart of the system. Today, we are moving forward by modeling the servos and BLDC motor in Fusion 360. These models are critical to ensuring everything fits and functions perfectly. By the end of this video, you will have the motor and servo designs ready to integrate into the mechanism. Let's dive in. So these are the servo and the motor that I am planning to model. As you see, it's a brushless DC. And another one is the standard 9G micro servo. I already have their dimensions as a sketch, so I will use that values in modeling process. Okay, let's create a new component. It will be the servo component, so we name it like that. It's a separate component from gimbal. And its subcomponents will be the motor itself, the body, and the other component will be the rotor. But for now, let's create the body. We already have the dimensions of the body, so we are creating a sketch and creating the profile of the body. I'm just passing these parts fast. Okay, now our profile is ready. We'll extrude this profile to have the main body of the servo motor. The width of the body was 12.5 millimeters. And now that small cylindrical region on the rotor shaft. We'll have a centered two cylinder that's intersecting together. The first one was 11.5 millimeters in diameter. And the second one will be 5.5. That two will be intersecting. Finish the sketch, and now the simple extrusion will be enough for us. The height was 4 millimeter for this part. And body is almost done. One last piece is for the cable that's coming out of the servo. The exact site is not important, but while we're modeling something, we don't want to forget these parts while creating a base or casing. So it's better to have it in the model. I'm just creating a rectangular region, more or less covering the cables. So actual cable section is much smaller than this region. And then I will extrude it. A half a centimeter will be enough because that cables can be turned around, bent in that region. But there should be a clearance. Whatever we model in that case, a case or sorry, a mount for the servo, we should care about this region. Now, body looks okay, and we will create the rotor component. Let's name it rotor. Actually, no, not rotor. Maybe arm, servo arm is more suitable in that case. We'll start by doing the rotor part, still at the center of that big circle. Diameter was 7 millimeters there. The height is again 4 millimeters. And now we can model the horn. The overall length of the horn was 20 millimeters. Of course, it's in your servo, it can be different. Actually, you know that servos are coming with so many different horns, but in my model it's like that. And the tip of the horn was a circular area with 4 millimeters in diameter. And now we will have two lines that's going from small circle to big one. As you see, the tangency can be achieved like that. And then I will do the same for the other circle. From the constraint sections, tangent. Yep, that symbol shows us that tangency is achieved. The profile of the horn is done, but actually we need that small holes for connection. Every hole is 1 millimeter of diameter, and we have 6 of them. We'll create a rectangular pattern for this. And distance will be 10 millimeters actually between each circle. Looks okay actually, it's not that important. But it looks like the real servo. Now we'll extrude this region as a part of the rotor. It was 1.4 millimeters, not cut but join. Looks fine. Okay, the geometry of the servo is done. Let's save it. Now we will add a joint. It's revolute. Looks okay, let's try. Okay, the axis is right. You can give that motion limits. In my servo it's minus and plus 45 degrees. It's different in different servo systems, but yep, looks okay. So, servo is done. Now let's create the motor. We use both of them, both of these models to have our assembly as a complete assembly. We named the new component as motors, and it will have some subcomponents. I will start by just marking the overall section of the motor. It's 28 millimeters in diameter. I will use that circle for both parts, both the base, stator, and the rotor part of the motor. So finish the sketch, and let's create a subcomponents. First, let's do the stator parts. Another one will be rotor, obviously. So we'll just extrude this circular area. The height of the stator was 8.5 millimeters. I don't know which direction to use, but actually just doing everything on the positive side. It's completely up to you now. It's not important actually. Okay, let's do it like that. Okay, it's the stator, actually visible part of the stator. Of course, the main part of the stator will be inside of the rotor in this motor, but not important. Now, a critical parts, we'll add that screw holes on the bottom. That all the screw holes are placed around a circle of 16 millimeters. As a reference, we are just adding a dot here. One of the holes will be there. Let's create the hole. It will be a simple hole, as you know from that BLDC engines. We will use tapped type of hole with threads, but drill point is flat. Actually, in actual motor, it's empty on the other side of the hole, but we know that stator cables lines are there, so we don't want our screw to go in that region. The depth of this hole was 2.5 millimeters, and when we choose tapped after finding the correct diameter for the hole, actually it's just choosing the right kind of screw hole for us. As you see, it's metric 3 hole with nice threads inside. Looks okay, let's create it. And now we'll have a circular pattern to have 4 of them. We can choose it by using that timeline, but first switch to faces. As you see, all the surface created in that step will be chosen. As an axis, you can just choose that circular region, and 4 of them looks fine. One last cylinder, actually it's not a simple cylinder, but you know, in most of that kind of motors, a small part of the shaft is coming on the bottom, other side of the stator, and we don't want our base, our mount, to touch this rotating part. So it's nice to have that kind of precaution here. So if we are modeling the mount, that intersection will give us some problems. It will make us remember that we should have a hollow region there. Okay, now we are creating this rotor part from the same profile. Again, it's a cylindrical body. Another cylinder, it's in some motors it's like that. It may change, but in our motor, there's another cylinder over the main cylinder like that. And lastly, the shaft. Its height was 12.6 millimeters. I think the geometry is done. Looks okay. Some details are just omitted, but it's not a problem. We want it as a reference in our design, not to model or produce the exact engine. Now let's add the joint part. It's a revolute joint on that intersection. And see, looks okay. Actually, we could add something to the rotor to see if it's turning around, but looks like the axis is right and it's turning properly. If there's a problem, we will see it later. So it's done. The motor is done too. So we're ready to model our servo mounts. Thanks for watching part 2 of our thrust vectoring system series. Now that we have modeled the servos and BLDC motor, we are ready to move on. In the next video, we'll design the servo mounts and finalize the system, preparing it for slicing, printing, and assembly. If you enjoyed this video, please like, comment, and subscribe to Scaled Factory for more content like this. Have questions or ideas? Drop them in the comments below. I would love to hear from you. See you in the next one.